Okay, so on example 6, we're going to try that again, and then you already know what's about to happen, but we're going to talk about it and how to fix it. All right, so if I substitute in, just like we did on the last one, or last two, so I have the sine of pi over 2 minus 1 divided by the cosine of pi over, we'll go with that, we're going to go with it, cosine pi over 2 and then squared. All right, so up here, once again, pi over 2, our coordinates are 0, 1. So our two values, that's the cosine and that's the sine. So the sine is 1, so that's 1 minus 1 up top. And then on the bottom, you have 0 squared. All right, so as you know, this is 0 over 0, and that gives us indeterminate form. So there you are. Indeterminate form. Now, so what can you do? Well, we're supposed to be able to do some sort of trick on that, all right? Some sort of algebraic manipulation. In this case, we're going to be using some things that we know about trigonometry, okay? So this is, you don't have to learn or remember, I should say, all of the identities that you learned in pre-calculus, but Pythagorean identity is one that you need to know, all right? So let's talk about that. And this is kind of cool. They showed the graph, all right? We were approaching pi over 2. So that'd be around in here. So it looks like you definitely, there's something that's approaching for sure. Okay. So here's what we're going to do. All right. So I'm going to start. So we have the limit as x approaches. They use x, theta. All right. So as theta approaches pi over 2 of sine theta minus 1 over cosine squared. Okay, so a little reminder over here. Your Pythagorean identity, and man, there's a million ways to prove this one. It's sine squared plus cosine squared is equal to 1. Okay. Okay, so if that's true, then cosine squared would equal 1 minus sine squared. Okay, so I'm going to make that substitution right now. So here we go. So this is equal to the limit as theta approaches pi over 2 of numerator just like it was, and denominator now something that's going to factor. 1 minus sine squared theta, which is the difference of two squares. That is that will factor as 1 plus sine theta and 1 minus sine theta, which then I can substitute. I mean, I can simplify. So that's our goal. So here we go. So I've got the limit as theta approaches pi over 2 of numerator like it was and denominator factored. 1 plus sine theta and 1 minus sine theta. Awesome. Okay, now, and that'll simplify, but here's the thing. Those two are not exactly the same, but if I do divide them, I'm left with a -1. Okay, so this will equal -1 divided by 1 plus sine pi over 2. Okay, and we already talked about that. We've had sine pi over 2 a couple of times now. So back up here at pi over 2, your y coordinate is your sine value, and so that is 1. So this is going to be -1 plus, over 1 plus 1. My limit is -1/2.